Hello everyone. Welcome once again to another natural language processing or NLP related tutorial by Slidescope. And in this tutorial, we are learning about an end-to-end NLP pipeline. So if we have understanding of a pipeline that we have to follow or that we have to use in NLP, so we will easily understand the series of steps to process and analyze the text data or what sort of actions will be performed. So below is an overview of the typical steps in an end-to-end NLP pipeline with basic explanations and some examples for better understanding. But the thing is, we will create chapters related to these steps. So there will be specific chapters or probably more than one chapter will be there for one step with more examples, with in-depth details so that you can understand them with Python language. In this chapter, your goal is to just understand these steps so that you can keep in mind when we will learn them one by one. The first step, how will you start natural language processing? The first step is obviously text acquisition, is to select data or acquire data. Okay, so whether it's data analysis, whether it's data science or anything, it starts with collecting raw text data or collecting data. Okay, so purpose is to collect raw text data from various sources. Now, what are these sources? You can do web scraping, you can scrape data from the web, you can use official APIs. There are many APIs available which will provide you data related to any context. There are social media APIs, there is user generated content, or there are many public data sets available on resources like Kaggle, GitHub, etc. Here we are seeing a very simple example here, and this example is text is equal to NLP is amazing, text processing can be challenging, and machine learning powers NLP. So here you can see we have a list. So in Python, a square bracket is a list, and in this list you can see we have comma separated three strings or three sentences. First sentence is LLP is amazing, second is text processing can be challenging, and third is machine learning powers NLP. So this is one example. You can take sample text data, you can connect with any database also. Suppose uh, you want to create a chatbot for your organization, and for your chatbot you want to use a data set. So so in your data set you can take help of your existing database. So your database may be present in any popular RDBMS or to like MySQL, PostgreSQL, Oracle or anything. So you will have your database where many user queries will be there, and you must have answered those user queries. So you must have answered those queries. So you must have some kind of database where the questions that user asked you and the answers that you gave to them will be stored, and you can use this supervised you can use this data set as the supervised data set, because here you know for which question which answer should be given. Okay, so you can use that. There are many pre-trained models available, there are many data sets available that you can use. So obviously we will learn more about this, but this is the most important first step is text acquisition. You should learn how to acquire the text for your project. When you are trying to solve a problem, in order to solve the problem and in order to make your machine learn about things, that is, NLP. So in order to make your machine learn and understand the problem, the user queries, and give answer based on them, you have to think of from where you can collect the data. After you have collected the data, the second step is text pre-processing. That means you have to pre-process the text. This means the purpose of this step is to clean and prepare text data for analysis. So we will create a specific chapter where we will explain this code, like what is written here, or what is lemmatization, what is tokenization, what is lower casing, what is stop word removal. So in a series of videos you will see that, but these are some steps that you have to get familiar with. That is stop word removal. Tokenization is breaking text into words or sentences. So you have to, if you have entire text, just break them into sentences or words. Lower casing is done to lowercase for uniformity, so that when you will compare lowercase with lowercase. Lemmatization and stemming is used to reduce word to their base form. For example, running can be reduced to its base form, run. Okay, so you will learn all of this. We have dedicated a video for this, and here is one example which we will understand later. In this video we are just understanding the steps in easy to understand language. If there is anything that you are not understanding right now, you don't have to worry about it. In upcoming chapters, when you will see examples, when you will see more detailed explanations, then you will easily understand them. Third one is text representation. So once you have acquired the text, you have processed the text, so after acquiring and processing, then you have to do text representation. This means convert text into numerical format for analysis by machine learning models. So actually your machine learning models are going to understand the text, you know, and on the basis of text they are going to perform some tasks. But machine cannot understand these texts. So what we do is we convert these text into numerical formats for analysis or for processing. Okay, some techniques used in text representation are bag of words that represent text as frequency of words. You will just see after explaining these techniques, I will give you a very simple example. Then we have TF IDF, which is where it weighs words on the basis of their importance. Okay, so if you will Google, it means term frequency and inverse document frequency. Okay, TF IDF. So TF IDF is a very useful technique and a widely used technique. Then we have some word embedding techniques also. Dense vector representation capturing semantic meaning. Example, word to vector, globy. When we are learning about text representation, there are some alternative terms that are used for text representation. Okay. First is feature extraction for text. Here the numbering is wrong. Don't worry. Just consider it as unordered list. Sometimes text representation is also called as feature extraction. Emphasizes the process of extracting features from text data for analysis. Sometimes it is also known as text vectorization. This is very important thing. Highlights the transformation of text into numerical vectors. Okay. So when we transform the text into numerical values. That is text vectorization. We will learn more about it. Then we have text embedding. This is a more modern term, especially used in deep learning, referring to dense representations of text, that is word to vec, globy, BERT or BERT. We will understand this. Basically, whatever terms you are reading right now, like TF, IDF, word to vec, globy, BERT, these are the things that you have to learn. These are the techniques that you have to learn. And when you will learn that, then you will gain more hands-on knowledge on NLP, and then you can say you have learned NLP. Similar to text vectorization, it is also called numerical representation of text. So you can call it text vectorization, or you can call it simply numerical representation of text. Describe the overall process of converting text into number for computational models. It is also called text encoding, word representation, linguistic feature representation, natural language vectorization, sometimes bag of words, which is bow, semantic representation, focus on capturing the meaning and context of text, contextual embeddings like BERT, and language modeling features. In traditional NLP, terms like feature extraction, PO, and TFDF are common. In modern NLP, terms like text embedding, contextual representation, and semantic representation, these terms dominate. Okay, so these are some use in context. So now let's see an example when we are saying that we are converting text into numerical format. Although we will learn text representation in great detail, but here we are trying to learn a very basic concept. There is a very simple Python program. You don't have to worry about it, like what is the meaning. I will just explain it to you. So if you have to start, you can type something like Google Colab. Okay, you can open Google Colab. So Google Colab is an IDE that you can use to run your Python programs. Okay. In upcoming chapters, you will also learn more about more type of IDEs that you can use, and how you can install Python, how you can install Jupyter Notebook, which will be used in your computer. But if you don't want to install and still want to test things, still want to try out NLP or create programs, then Google Colab Notebook can be used. In simple words, it is where you will write your programs. Here you will click new notebook and it will open something like this. Okay. And when you will open something like this, here there are cells, or there are these lines where you will type your code. For example, if I type print 5 plus 6 and I run this, so it will simply give me the sum of this. So this is a very basic understanding. You can delete cells. So here we have pasted that text which we created. So from sklearn.feature extraction, as we said, the name can be something like this. So what we are doing is text representation, but in sklearn, which is scikit-learn, a machine learning library of Python, from sklearn we are importing feature extraction and using text, and we are importing TF-IDF vectorizer. So we just learned the meaning of TF-IDF. This is TF-IDF vectorizer that will convert the text data into numerical data. Text is NLP is fun. I love learning NLP. So first we have acquired the text, and after acquiring the text we are doing some text pre-processing, that is vectorizing the text. That means changing the sentences into words. So NLP is fun. I love learning NLP is a list. Here we have two sentences. Vectorizer, TF idea vectorizer. So we are creating an object here of this TF idea vectorizer. this object can now use the methods of this class. So now we are creating a TF IDF matrix, okay, where frequency and IDF will be saved. So we are saying vectorizer fit transform the text, and text is what? This list. So first we have the text, then we create a vectorizer, and in vectorizer we are fitting and transforming the text. Now vectorizer can access other methods also of this class, and one method is get feature names out. So this is feature extraction. What are the features? So you can see it is, it will give output like fun is learning love NLP. Okay, so fun is learning love NLP. It will give something like this. Okay, which you can see the output here. So it has extracted the feature names, and then we are creating the TF IDX matrix. Remember, TF IDF is term frequency and inverse document frequency. These are two type of frequencies. So which we will understand later also. But here you can see, all you have to understand is this complete process, whether or not right now you understand it, maybe you get some basic idea, but just stick with this series, you will understand all of this. You have to understand this 5 or 6 line of code what has it done. It has, you know, done feature extraction for us, and it has done this for us. It has done text representation for us. It has converted the text into numerical format for analysis by machine learning models. So when we ran this code in Google Colab, the output we got from this input is fun is learning love NLP. So it has given us NLP, fun, learning, love. I is not there, all the spaces are not there. So it has broken down the sentences into this output. And then it is giving us some numbers. Okay. So it is giving us a metric or a matrix with some numbers. The output you provided represents TF IDF term frequency inverse document frequency transformation of the input text, which convert text into numerical format suitable for machine learning models, which we learned so far. So vectorizer.get feature name out, result is this. This is the vocabulary extracted from the input text. NLP is fun and I love learning NLP. Each word appears as a column in the transform numerical matrix. So you can see each word appears as a column. Fun is learning, love, NLP. Then TF IDF matrix to array is this result. Each row correspond to a document. So NLP is fun is row 1 and row 2 is I love learning NLP. Each column correspond to a word from the vocabulary. Fun is learning love NLP. So each column correspond to the word, and each value represent the TF-IDF score for the word in the document. So score for the word in document, which you will just understand. TF stands for term frequency, counts how often a word appears in a document. Example in NLP is fun. The word NLP appears 1, so its frequency is 1. IDF inverse document frequency measures how unique a word is across all documents. Words that appear in many documents get lower scores. Example is. So NLP is fun. I love learning NLP. So words that appear in many documents like is, I, they get lower scores. TF IDF is score. It combines TF and IDF. Let me fix the formula. So the formula is TF-IDF is TF multiplied by IDF. That means it will multiply the term frequency with the score, how unique a word is across all documents. Okay. Fun has 0.63, high importance in this document. Is has 0.6316, moderate important, less unique. NLP 0.44, shared across documents, so less unique. Learning and love 0, don't appear in this document. So the document that we have fun is learning, love, NLP. And row 2 has, so this is row 1, NLP is fun, and this is row 2, I love learning, NLP. So here learning is important in this part, in this document. Love is important. NLP has the same value because it is shared. Fun and is 0 0 because they are not, they don't appear in this document. So that's why you are seeing like this: 0 0, then 0.63, 0.63, 0.442. I love learning NLP. I 0, love 0 because they are not appearing. Learning NLP. Okay. So love learning NLP. So that's why it is giving that output. So we will understand this more, uh, that how is this happening. But with this matrix, uh, Python will be able to understand easily the importance of these words, and high TF IDF scores. Words unique to document get high scores, indicating that they are more important for that document. Words appearing in many documents or commonly used words get lower scores. We will get more examples to make this more easy to understand, but here you just have to understand, the only thing that you have to focus on is we have this process where we have text acquisition, text pre-processing, and text representation. After doing text representation, we also have feature engineering. Feature engineering is a big topic. It is in data analysis or data science or AI. Its purpose is to enhance text features for better performance. Examples are adding part of speech tags, extracting n-grams. What is n-gram? What is POS tags? Is something that we are going to learn. Calculating sentiment or text length. So here one simple example is that they are using another library, that is Spacey, which we will learn separately. Then in Spacey we are loading Encore Web SM. What is this? We will understand. But you have to understand that the document is NLP is fun and interesting. So for token in doc, print token text, token part of speech. It will print token with part of speech. So let's run this code. So we will simply go to our collab file, and in our collab file we will import a spacey and perform this task. So here you can see NLP propen is ox, one adjective, and CC conjunction, interesting adjective, punctuation. So what does this mean? Okay, what it is doing is, first of all, it is, you know, breaking down each sentence in tokens, like NLP is fun and interesting, and dot is a punctuation. Okay, so is a auxiliary verb, and fun is adjective, and is a conjunction, interesting is an adjective. So NLP is a proper noun, is an auxiliary verb, and so on. So it is giving us point of the parts of speech tags. Okay, and also doing the tokenization, that is breaking the sentence into words. So you will learn tokenization in later chapters also, but you can see what is feature engineering. Enhance text features for better performance. So we have enhanced the text features with adding part of speech tags. We will also learn about n-grams, etc. Then in the pipeline there is model selection. There are many models available for many type of programs, for many type of problems, solving them, many type of data that we can have. So in model selection, we select and train a machine learning model to solve the NLP problem. And for example, for text classification, logistic regression, SVM, and naive Bayes classifiers are used. For sequence models, LSTMs, GRUs, and transformers like BERT and GPT are used. So when we will proceed with some project in NLP, whatever model we will use, we will explain the theory of that model, like why that model, and the programming related to that model also. And if you have some basic understanding of machine learning, then obviously you must have heard about these models. So here is some example which we are going to cover later, but we have kept examples and we will give this description so that later when you have some more understanding of these concepts, you can try these examples yourself and see the type of output you are getting and understand the concept. So we have done text acquisition, we have done text pre-processing, we have done text representation, we have done the feature engineering, that is we have enhanced the text features for better performance, we have done model selection. Then we have selected the model, but then we have to evaluate also, like what is model's performance. So we assess model performance using metrics like their accuracy, their precision, their recall, and F1 score. Tools that will be used here are classification report, confusion matrix, etc. And it will be there in sklearn. So if a model has predicted on test data, so what is the classification report? So we train the model on training data, and then we test the model on test data, and how well has the model performed on the testing data comes in the report. So we will learn that. After evaluation, you will do post processing. That is, you will enhance the output for better user understanding. These outputs are easier to understand for data scientists and programmers and all, but for better user understanding, you will do post processing, that is converting probabilities into categories, highlighting important entities in text, which we will learn in NER. Then deployment. So your model is created, your model is able to process everything. Suppose you have created a chatbot. So you will provide that chatbot somewhere. And for deployment, we serve the NLP model in real world applications. For example, this is a simple website which is also deployed, right? So you can create RESTful APIs with the help of Flask, or you can even create a complete web application where your model will be used, which you will learn later. So you will create your chatbots and it will be available on a browser. It will have a user interface where users can interact with your chatbot. Or for example, Google Translate. If you have an interface where you enter some text and Google translates it for you, or Google search where you enter some text and Google gives you the output. All of them are using NLP and they are kind of deployments. Even YouTube, where you can voice search anything. So For deployment, a module of Python called Flask will be used. Flask can be used to create web applications or create RESTful APIs. For example, module like Fast API can be used to do that. How will it be done? That is something that you are going to learn, and that's why it is a complete series, not just one video. Some use cases are, let's say we are doing sentimental analysis and user inputs, I love learning NLP but hate spam emails. Pipeline will be pre-processing, tokenization, stop word removal, and lemmatization, that is reducing word to their base form. Text representation with TF IDF vectorization. Then here we will use model like naive Bayes classifier, which we will understand how it works, and output will be sentiment prediction for each sentence. So here there is one sentence, so it will predict some sentiment for it, positive, negative, neutral, those type of things. So this is an entire pipeline here. If you will keep this pipeline in mind, then whatever NLP project you are doing, you will be able to perform it easily. I hope you understood this concept. Please watch the next videos in this series so that you can start creating your simple programs. You can start performing these pipeline tasks.